answers. With limits, we have always talked about a limit is how it approaches from the left and the right, correct? Now, if a limit exists at that value, it means that from the left and the right it's the same value, yes? So, in order for a graph to be continuous, from the left, I really don't adapt. Every day I do. Okay, from the left and from the right, it approaches the same what? What value? Same y value, yes? So a graph is continuous, or it has a limit, if from the left and the right it approaches the same y value, correct? Would this make it continuous? The limit exists, but is that graph continuous? No. So in order for it to be continuous, I need to be from the left and the right the same value, but what do I also need? In order for a graph to be continuous, left and right is the same, and then what? F of that value has to be the same. Yes? So you have to, from the left, add that value, and then exiting it from the right, same value. Yes? So that's why we have this. The definition requires three things. F of A is defined, so that means F of A exists. And then the limit as x approaches f of x exists, and then those are the same. So if you want to prove continuity, you have to prove that the limit exists, f at that value exists, and that they're actually equal. So you have to do 3 steps. 3 steps, and I put 2 fingers. Awesome. 3 steps. 1, find f of a. 2, find the limit at a. 3, say that they're the same. That's it. That proves continuity. All right. So let's look down here. Here we have a graph, not mathematics, not algebra yet. So here it says, at which numbers is f discontinuous? So you can show that it's not continuous by it not working. Either the limit doesn't exist. If the limit immediately doesn't exist, you're done. If f of a doesn't exist, you're done. Okay? So, that 1, so it's continuous. I might watch this. It's crazy. Continuous. I didn't lift my pencil. And this is not a pencil, whatever it is, marker. Anytime I have to lift my pen, is the graph continuous? No. So we have to say they're not continuous, but why are they not continuous? So sometimes it's because the limit doesn't exist. They don't approach the same thing from the left and the right. Sometimes it's that f of a doesn't exist, right? So for number 1, for the number 1, x equals 1, why is it not continuous? Yeah. F of a doesn't exist. Does the limit exist? Yeah. Yep. The limit is whatever the heck this y value would be that corresponds with it, correct? So x of equals to 1, and why is it discontinuous? Because f of 1 does not exist. So f at the value, if it doesn't exist, it's done. If the limit at that value doesn't exist, it's done. It can't be continuous, correct? Because I need it to be the limit to be the same and f of a to be the same. Where's the next place it's not continuous? Yeah. 3. Is it because f of 3 doesn't exist? No. F of 3 does exist. It's this dot, correct? Why is it a problem? Why is it not continuous? Yeah. So the left of 3 approaches some negative number. The right of 3 approaches some positive number. They don't approach the same thing, right? So then x equals 3 is discontinuous because the limit as x approaches 3, and this is an f function, so of f of x, does not exist. So sometimes the limit doesn't exist, sometimes f of x doesn't, like the f of a value doesn't exist, sometimes both of them don't exist. But the moment one of them doesn't exist, you're done. It's not continuous. Okay, where else? Okay, 5. Why?
Because f of x, limit of f of x doesn't equal f of a.
Right. But what's the kicker here? So the limit works, but what doesn't work? F of 5 works, right? But what doesn't work? The two of them together doesn't work. So, some people will say to me, the limit as x approaches 5 of f of x is a value. We're going to make that value be, I'm going to label it as A. So the limit as x approaches f of x equals A. Then f of 5, like Devin said, it also exists. So that's not the problem. They both exist. The problem is they're not the same. So f of 5, let's pretend it's B. So these exist. That is not the issue, which you're completely correct with. What he said is they don't equal each other, which is completely correct. So this one equals A, this one equals B. That's good. They both exist. But the limit as x approaches 5 of f of x does not equal f of 5. And that's why it's not continuous. Because we have to go through, get the same value, come back out, which we can. Yeah? Okay. Flip over. We're halfway done our lesson. It's a super long one. What? It didn't print the next page. The first one is a little easier to figure out where it doesn't exist or where it's discontinuous because it's from 30-1 and we just all finished it for the most part, right? So where is our errors are when our denominator would equal 0. We agree? So this one is x equals, oops, once again, not a fast learner here. Okay, x equals 2. Now we have to decide, is it an asymptote or is it a point of discontinuity, which is called a removable discontinuity in calculus? X minus 2, x plus 1, x minus 2. Since it cancels, it's a removable discontinuity. Yes? So the limit will exist. If it's a removable discontinuity, your limit will exist because from the left and the right, it's approaching the same y value, whatever that point of discontinuity's y value is. And what would that y value be? Well, now we can plug it in. We get 2 plus 1, and we would get 3. So actually, to prove a point here, the limit as x approaches 2 of f of x equals 3. The limit is not the issue, right? From the left and the right, it's approaching that same point of discontinuity, that open dot at 3. Yes? The issue is that at f of 2, there's nothing. It's an open dot, right? So f of 2 does not exist. So that is why it's discontinuous, if you're asked to explain why. The limit is fine. And from the left, it approaches 3. From the right, it approaches 3. But at 2, there's nothing. It's an open dot. There's a gap, right? B and C are a little more complicated because we're talking about piecewise functions, and those are a little bit harder to understand. So if we want the limit, we need from the left and the right. So basically, we need everything but 0, right? So if this is when x can't equal 0. So that's the left and the right, yes? So if I did the limit as x approaches 0 from the left, I would use this formula, 1 over x squared, and it wouldn't exist. And we could do it from the right, and it wouldn't exist. But we would get asymptotes. So from the left, put in 1 over x squared into your calculator if you want. One of them is going to approach positive infinity, one of them is going to approach negative infinity on the opposite sides of 0. So when we have 1 over x squared, x squared, not 1 over x. So they're both approaching positive infinity. Now, we would get 1 over x squared, this would be infinity, and the limit as x approaches 0 from the right, 1 over x squared is infinity. What is f of 0 equal to? What is f of 0 equal to in this equation? When x equals 0, y equals what? 1. Are they the same thing? So it's not continuous at x equals 0. So this one we have to check our limit. So we can do the limit as x approaches 2. The limit is not what it equals, it's what it's approaching. So we're going to use this formula, the x squared minus x minus 2 formula over x minus 2. If I plug it in right now, if I substitute in the 2 right now, do we have problems? Yes. So yesterday, what did we do? We factored and tried to get rid of it. Correct? So we rewrite it again. We get the limit, an equal sign, and then the limit again because we haven't substituted in. And the top factors to x minus 2, x plus 1, over x minus 2. The x minus 2's cancel off. Now can I sub in? Yep. So now I have 2 plus 1, the limit goes away, and it's 3. So the limit is equal to 3. So the only way this is a continuous function is if the limit is equal to 3 when I plug in a 2, and when I do f of 2, it's equal to 3. Because then it would be 3 from the left, 3 at 2, 3 carrying out. Correct? What is f of 2 equal to? When x equals 2, 1. Are they the same? No. So it's not continuous at x equals 2. And if they asked why, I would say because the limit as x approaches 2 of f of x does not equal f. That would be my explanation. All right, then we're going to flip over. And hopefully it printed it. I'm going to hold out the hope until I press this. Ah, winning. All right. What I want you to do before we even discuss continuity or anything is graph this graph. So try and graph that piecewise function on this Cartesian plane, remembering that you have to say x scale, whatever you want it to be. It's probably going to be a 1, and y scale, whatever you want it to be, and it's probably going to be a 1. Okay? Try it out. Use pencil. If we want to, we could draw 3 t-tables. So this one would be an x and an x plus 1, knowing for the fact, though, that it has to be x less than or equal to 1. So I start with a 1. I go 1 plus 1, which is 2. Closed dot or open dot? Why? Because it's less than or equal to. So I have 1, 2, closed dot. Then I can use 0 because I have to use less than it. So I go 0 plus 1, which is 1. So now I have 0, 1. And then if I use negative 1, I get negative 1 plus 1, which is 0. And it's a line, so it's just going to keep going. Down one. And with an arrow. It keeps going. Okay. Then we have 1 over x as our second t-table. So it would be x and then 1 over x. And it's between the values of 1, 2, and 3. That's supposed to be an x. So I do 1 divided by 1, which is 1. So now I have a coordinate at 1, 1. Open or closed dot? Open because it's between 1 and 3, not inclusive. So 1, 1, open dot. Then I have 1 over 2. So it's 2 and 0.5. Close dot. Then I have 3 and a third, which is 0.33333 repeating. Open dot. Right? Connect. Just a small piece of a rational graph. Okay. Then my third one. So we have square root x minus 3. And this one is x is greater than or equal to 3. So we have to use 3 first. When we use 3, we get square root of 3 minus 3, and it's 0. Closed dot or open dot? 3, 0, closed dot or open dot? close dot because it's equal to 3. And then I could use 4. Square root of 4 minus 3 is square root of 1. I get 4, 1. And then I could use 10. 10 minus, oh, it's 3. That's a stupid option. 13, 14. Oh, we're running out of room. I don't know. Square root of 4. Let's do 7. This is a 7. 7 minus 3 is root 4, which is 2, so we get 7 and 2. So it would look like that. Where are my breaks? Yeah. At 1 and 3. 3. You got there. At 1 and 3. So x equals 1 and x equals 3. Now, that's because we drew it. Can we actually show that it's at 1 and 3 algebraically, not having to graph the graph? Yes. So, we're going to prove it first by limits. So if I go the limit as x approaches 1 from the left, which equation am I going to use? We have to be able to do this algebraically, so everyone's following along. If I want the limit as x approaches 1 from the left, which equation am I going to use, Marcus? The top one, because it's when it's less than, right? From the left is less than 1, from the right is greater than 1. So I have to use the less than equation. So I'm going to put x plus 1 beside it, and then I can fill in. I get 1 plus 1, and I get a 2, which is what we have sitting here. We have 1, 2 from the left, correct? Then I show it from the right. The limit, as if you're like not writing this down because you're like, I'm just going to use the graph, cool, except when I ask you to do it algebraically on the test, you're pooched. So please write this down. Please. Okay, the limit is x approaches 1 from the right. Which equation am I going to use? Top, middle, or bottom? Middle, because I need greater than 1. So it's going to be 1 over x. So I write that one beside, and then I do 1 over 1, which is 1. And then the limit, therefore the limit as x approaches 1 of f of x does not exist. And the moment that it doesn't exist, we're done. Can't be continuous, right? Left and right are approaching different values. All right, what about 3? The limit as x approaches 3 from the left. Which equation is 3 from the left? Middle or bottom? Middle, because it has to be less than 3, correct? And the less than 3 equation matches with 1 over x. So I get 1 over 3, and it equals a third. Then I do the limit as x approaches 3 from the right. Which equation am I using? Greater than 3 equation, so the bottom. So I go square root x minus 3. And then I plug it in, I get 3 minus 3, which is 0. Do they match? No. So therefore, the limit as x approaches 3 of f of x does not exist. Last thing we're going to do is the intermediate value theorem, which sounds excessively hard, and it's not. So don't let the theorem throw you off. The intermediate value theorem, supposed that f is continuous on the closed interval ab, and let n be any number between f of a and f of b, where f of a can't equal f of b, then there exists a number c in ab such that f of c equals n. Okay. The intermediate value theorem is this in layman's terms. Ready? If f of a is some value, like let's pretend 1, the answer to f of a is 1. And the answer to f of b is negative 6. And the graph is continuous. Then there exists y values, an x value somewhere along the lines, where a y would be between 1 and negative 6. So, this is what I'm saying. If I have f of a, and let's say it is f of a equals 2, right? And I have f of b, and it equals 7. The key thing to intermediate value theorem is the graph has to be continuous, right? There exists somewhere along the lines. I could have a graph like that. I could have a graph like that, right? I could have a graph that does this. Ooh, can't do that. That's too high. Bad graph. Are you serious? It's probably frozen again. Okay, whatever. There, the graph. Pretend this doesn't exist. There, it's gone. I don't even. It's not erasing either anymore. There exists a graph that I could go like this. So somewhere along the lines, there's an x value on that graph that will fall with a y value between 2 and 7. That's all it's saying, right? If your lowest endpoint is 6 and your highest endpoint is 20, then there's going to be an x somewhere along there where there's a y between 6 and 20. That's all it's saying. So let's look at this one. Oh boy. I'm just going to keep writing really tiny at the bottom of this and hope for the best. Well, that's still working, so we're somewhere. So use the intermediate value theorem to show that there is a root. What is a root? Fancy way of saying what? A 0. Another fancy way of saying a what? X-intercept. And x-intercepts what's 0? Y. Y equals 0 when it's an x-intercept. Okay, we got there. I think I got us there. I don't think you got there, but that's okay. And use the intermediate value theorem to show that there's a root of the equation in the specified interval. So we're showing that there has to be a root between x equals 1 and 2. This is x value. This is a domain. It is rounded brackets. It is a domain. It is not an xy. Right? I can do domain in interval notation in brackets. It's an xx, correct? So what they're saying here is between 1 and 2, there has to exist an x-intercept on that graph. In order to use the intermediate value theorem, there are two things we have to show. One, we have to state first that this is a continuous graph. Is this a continuous graph? 4x cubed, blah, 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 blah. Are cubic graphs continuous? Are cubic graphs polynomials? Yes. So we have to first state that this graph is continuous between 1 and 2. So the function is cubic, and therefore continuous, I can't erase, continuous between 1, 2. So we have to first state continuity, because if I get you an x or get you two y values, but I don't tell you it's continuous, could there be just those two y values and they never connect? Yes. So I have to state that the graph is continuous, and then I need to find the two y values. And as long as one y value is negative and one y value is positive, is it going to have to cross through the x-axis somewhere? Yes, that's it. So it's 2 steps. 1, state that it's continuous. So it has to be between those values. 2, find f of the two values. So I'm going to find f of 1. So I'm going to get 4 times 1 cubed minus 6 times 1 squared plus 3 times 1 minus 2. And some people say, well, why can't I just find the x-intercepts? Because it didn't ask you to find the x-intercepts. It says using intermediate value theorem show that there is going to be an x-intercept. So I have 4 minus 6 plus 3 minus 2. So I have 7 minus 8, so it's negative 1. And then I have to find f of 2, which is 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2. So I get 8 times 4, which is 32, minus 24 plus 6 minus 2. So it's 38 minus 28, 26. 38 minus 26, 12. Okay, can we say that there's going to be a 0 now? If one of the endpoints is below 0, it's at negative 1, and the other endpoint is 12, and I told you the graph is continuous, that means it's going to do this. From negative 1 to 12, it's going to do this at some point. Is it going to cross through 0? Yes. So that's you end it. Therefore, the graph is continuous, or the graph, oh my gosh. Therefore, there is a root. That falls between 1 and 2. So we said that the function is continuous between 1 and 2. We said that at 1 it's -1, at 2 it's 12. Well, if the function is continuous from 1 to 2, and it's from -1 to 12, at some point it's crossing through 0, right? So that's the intermediate value theorem. You have to have 1, that the graph is continuous in that interval. 2, what are the actual y values of that interval? 3, then it happens. So sometimes the y values will be 1 and 9, and they're asking you if there's a y value at 7. Well, would there be if it's continuous and the lowest is 1 and that top is 9? Yeah, at some point it's going to have to cross through 7. That's all the intermediate value theorem is. You have to say that it's continuous. You have to find the endpoints and say that's going to cross through there then. Because at some point, if it's crossing, if it's lower and higher and it has to connect, then it's going to have to cross through. That's what the intermediate value theorem is in this lovely word. Okay? It's letting me scroll again. I don't even know what's going on. Start working on it. Finish up to this for today. Now I know that sounds like a lot, but 17 to 21 odd is 3 questions. So that is 4. Go.